is actually chemical reactions. And so, overall, when it comes to reactions, we have some ways of kind of showing what's actually happening and some important parts that go into these equations. And so, first, all chemical reactions are described by what we call chemical equations. Now, these chemical equations show the reaction that's taking place by using the compounds or element symbols as a way of kind of showing what's actually happening. Now, the standard format is to always write the reactants first, and then this arrow, and we'll talk about what that arrow means in a second, and then our products second. So it always reads from left to right, reactants going in, products coming out. And so the reactants, like I said, are the things that are going into the reaction. And then once the reaction takes place, it produces the products, which is what we get at the end of the reaction. Now, another important thing is called the law of conservation of matter. And you guys have probably actually heard this before. The law of conservation of matter says matter cannot be created or destroyed. So you guys have probably heard that one, or the energy one, which is essentially the same. It says energy can't be created or destroyed. But in chemistry, we care about the idea of matter. And so it says matter cannot be created or destroyed, meaning all atoms in a reaction must turn into products. And so now let's talk about some helpful symbols that we're going to see as we go through writing out our reactions. So the first symbol that we're going to have is this plus sign. And our plus sign is our way of saying and or reacts with. Then our next one is that arrow that separates the reactants and the products. And that arrow usually means yields. And then finally, if we have arrows going both ways, forwards and backwards, this is what we call an equilibrium arrow. Now, equilibrium is, if it helps, if taken bio, it's kind of like the idea of like osmosis, where stuff can go forwards and backwards through like a membrane. So in chemistry, it's like a reaction takes place and then this opposite reaction takes place. So it's like reversible. Then some other symbols. We have, if we see an S in parentheses, that stands for solid. If we see an L, that means it's a liquid. If it's G, that means it's a gas. Pretty obvious, right? Then our last three that we need to know, too far. The last three that we need to know are this triangle, which represents heat. Now, if we see the triangle, generally it's going to be written above the yields arrow, and that's saying that you're heating the reactants in order to make the reaction occur. Now, another one would be if we have this info, and this would be above the reaction arrow. Now, whatever info is there, that generally means that this is a catalyst. Now, remember, if you guys haven't heard of catalysts before, the idea behind a catalyst is it's there, but it doesn't actually take place as part of the reaction. It simply speeds it up. And then finally, our last symbol, which we'll talk more about later, is AQ, which stands for aqueous. OUS. There we go. Now, if something is aqueous, that just means that it's dissolved in water. So if you're talking about, let's just say, salt, and you add it to a glass of water, you just made an aqueous solution as salt water. All right, so now that we've talked about some helpful symbols, let's talk about our next big topic that is important for reactions, and that's this idea of balancing equations. Now, we have to balance equations because, according to the law of conservation of matter, that does mean that we have the same number of atoms of each element as we do in the products, or in the reactants and in the products. Hopeful years didn't do this. So this is, in here we should have the word reactants, and over here we should have products. All right, and so let's look at some examples. Our first one here, we have Ki goes on to produce K plus I2. Now, one important thing, remember I2 is one of our Hankel-Briffs, so it's diatomic. And so that does mean that when it's by itself, it's I2, but over here, it's just Ki because iodine isn't by itself, it's bonded to the potassium. So that's why, in case you were wondering why it's not Ki with a little 2 here, it's because the Hankel-Briff rule only applies when it's written by itself. But anyways, let's get back to balancing. And so as we're balancing here, if we're counting up the number of everything, I like to use this kind of T-chart as reactants, products. Now, if for potassium, in the reactant side, we only have one of them, right? Because there's no little subscript. Then for our iodine, we also only have one. Then on the product side, we have one potassium. And in the product side for iodine, we actually have two of them. So that does mean that we need this to balance. Now, in order to balance, that does mean that in order to get the reactant side for iodine to a 2, that does mean that we need to multiply or put a 2 in front of Ki. Now, by doing that, that does multiply this by 2. So iodine is now okay, but it also multiplies the potassium by 2, which means that we now have 2 potassiums on the reactant side, which means that on the product side, we also need to add a 2 there. Now, something to keep in mind as we're adding these kind of numbers, which we call coefficients, as we add these coefficients, we can only add them as big numbers in front. We cannot add them as little subscripts as we balance, because remember, the compounds that are formed are because of, let's just say it's an ionic compound, it's because of the positive and negative charges balancing. So as you're balancing these, remember, you can never just change or add subscripts to these. So just something to keep in mind. But let's look at our next example here. So we got P4 plus O2 goes on to produce P2O3. And so as we're looking at this, we'll do our reactants and products chart. And so we have, in this case, phosphorus and oxygen. Now, on the reactant side for phosphorus, there's 4 of them because we have the little coefficient there. Then on the product side, we have 2 of them. Okay, that works. Then for our oxygens, we have 2 oxygens on our product side and 3 oxygens on our, 2 oxygens on our reactant side, 3 on our product side. So now, as we're looking at this, both our phosphorus and our oxygen aren't balanced. So let's just kind of pick one. Let's start off with our phosphorus. Now, if we're going to balance our phosphorus, if we take our 2 and we multiply it by 2, meaning we put a big 2 here, that gets us to 4. So now phosphorus is all balanced out. But since we also added the 2 there, it has the effect on the phosphorus as well. So the 2 also gets multiplied. Now, with that in mind, that does mean that we now have 6 oxygen as products. So that means we need to have 6 oxygens as reactants. Now, the good news is 2 is divisible by 6, right? So if we multiply it by 3, that gets us 6 oxygens on the left side. All right, so that's it for this one. Let's look at our next example. Here we got NaCl plus PBS turns into Na2S plus PbCl2. So as we're looking at this, a little bit more complicated now, but as we're looking at our reactants versus our products and dividing it up, we have Na, we have Cl, we have Pb, and we have S. Now, everything as a reactant is a 1. Now, as products, though, sodium, we have 2 sodiums, 1 sulfur, 1 lead, and 2 Cls. So remember, we got those from looking at the coefficient or the subscripts written after each of those. So now as we see this, the PBs and the S's are okay on both sides, but the Na and the Cl is not. And so that does mean that we need to multiply both Na and Cl by 2, which is good news because Na and Cl are together as reactants. So by multiplying those by 2, that does then balance out our equation. So now that we've talked about this, let's talk about what happens when you have to balance with polyatomic ions. Now I'm going to show you guys a little trick here. And so with our kind of balancing with polyatomic ions, the key is when you see polyatomic ions like NO3, what you want to try and do is instead of balancing the nitrogens and the oxygens separately, we're just going to balance NO3s. And so when we make our chart for reactants versus products, as we look at this, for our reactants, we're only going to list Cu, Ag, and NO3. So that's a little shortcut that we can take. And so for Cu, we got 1 of them, silver, we got 1 of them, and nitrate, we have 1 of them as reactants. Then as products, the copper is still 1. Ooh. Our silver is still 1, but our nitrates are now 2. So that means that we do need to balance out our nitrates. So we put a big 2 in front of our AgNO3, and that multiplies both the Ag and the NO3s by 2. So since we did that and we multiplied the Ag by 2, the NO3s are now okay, but Ags we still have to fix. So we need to go and multiply our product Ag by 2. So we had a big subscript or coefficient up front. And now finally, our last one, unfortunately, it didn't turn out quite as easy as our last one. We got tin 4 hydroxide, or SnOH4. But notice here, the hydroxide, our polyatomic ion, it breaks up. So we don't see OH anywhere as a product. So that does mean that we have to balance it separately. We can't balance the hydroxides like we did before with our nitrates. So now, as we make our reactants and products balancing chart, we have Sn, we have O, and we have H. Now for the Sn, to start off on the reactant side, that's a 1. Now, as we're looking at our products, our other reactants, this 4 means that it's multiplying the hydrogen by 4 and the oxygen by 4. So that means that there's 4 oxygens and 4 hydrogens. So now let's go back and let's look at our products. And so for the Sn, or the tin, there's still only 1. For the oxygens, there are 1, 2, 3 of them. And then for our hydrogens, there's only 2 of them. Now, when it comes to balancing stuff like this, whenever you're looking at your products and you're saying, oh, oxygens aren't balanced, so how can you make a 4 and a 3 balance? Well, because it's O2 here, we're going to try and avoid putting a coefficient in front. So instead, let's look at if we add a coefficient in front of H2O, if that ends up fixing our problems. And so let's look at hydrogens first. Now hydrogens, as it turns out, we have 4 as reactants, 2 as products. So that means if we add a or multiply our product's hydrogens by 2, we can add a big coefficient here. But once we did that, let's look and see what happens to our oxygens. So for our oxygens, after adding that 2, we now have 1, 2, and then because the 2 that we added means we multiply those oxygens by 2 as well. So that does mean that did actually give us the 1 oxygen that we needed to get up to 4. And so now our tins are balanced, our oxygens, and our hydrogens. All right, so now let's look at the next and last kind of little bit of this video, which is all about writing out our reactions. And so our reaction here, we have potassium bromide and chlorine react to form potassium chloride and bromine. Now, because potassium bromide is a compound, we should start by writing out the compound itself. So we're going to have an intermediate step before we write out our reaction. So potassium is K plus 1, and bromide is Br minus 1. And so those charges cancel out, which means that our compound, potassium bromide, is just KBr. So then it says, and chlorine. So plus Cl. Now, don't forget, chlorine is one of our Hunkelbriefs, so it's not just plus Cl, but plus Cl2. And then it says react to form, so that's where we draw our arrow. And then potassium chloride. Now, potassium we already said was plus 1. Now let's look at chlorine. And as it turns out, chloride is just Cl, also with a minus 1 charge. So that does mean it's just KCl. And then plus bromine. So that would be plus Br. Now, remember, bromine is also one of our Hunkelbriefs. So it's not just Br, but Br2. So now that we have our reaction written, now let's go through, because we can't skip the balancing step. And so as we're balancing, potassiums are balanced. Bromines, we have 1 as a reactant, 2 as products. So, okay, well, let's add a 2 there. Then let's check chlorines next. So chlorines, we have 2 as reactants, 1 as a product. Okay, well, if we only have 1 as a product, we had our coefficient of 2 in front of the KCl. And so now let's just double check that everything's balanced. Potassiums are balanced, bromines are balanced, and chlorines are balanced. All right, if it's all balanced, that means that then we're done. So let's look at another reaction. This one, we have lead 2 nitrate and sodium iodide react to form lead 2 iodide and sodium nitrate. Okay, well, a whole lot going on here. So we have lead 2 nitrate. So we have Pb plus 2, and nitrate is NO3 minus 1. So as our first compound here, remember we crisscross those charges, so that gives us Pb NO3 2 plus sodium iodide. So sodium is Na with a plus 1 charge, and iodide is I with a minus 1 charge. And so since we know that, that means it's NaI. And then it says react to form. So there's our arrow. And then it says lead 2 iodide. So lead, we already listed it. It was plus 2. Iodine is minus 1, which means that our compound should be PbI2 plus then the other part, sodium nitrate. So Na with a plus 1, NO3 with a minus 1. Okay, that means it's just NaNO3. And so now that we have our reaction written, remember our next step should be looking at balancing. So as we're balancing here, hopefully we saw that NO3s are not balanced, and right now I's are not balanced. So let's first start off by balancing out our NO3s. So if we balance out our NO3s, we need to add a 2 in front of our NaNO3 product. So now our nitrates balance. Now the other thing that didn't balance was the iodine. Let's see if we can fix that. So since there's 2 on the product side, that means that we need to add a 2 in front of our NaI reactant. And so now that we've fixed those, let's go back and double check everything. Leads, those balance. NO3s, those balance. NAs, balanced. I's, balanced. Now, if it helps as you guys are balancing, the way that I think it's the easiest way to kind of go through and balance all these reactions is to start off with your first element. So if I'm starting with PB, you just work from left to right, and you only have to do it across the reactants. So you balance the PBs first, then NO3s, then NAs, then I's. And 99% of the time, if you do that, everything will balance out. So don't worry about the fact that the first thing we did was add a two-way over here, which then changes the number of sodiums. Just work your way from left to right across the reactants. And by the time you get to the last reactant, everything should be balanced out. All right, with that in mind, let's look at our last example here. And so for our last example, we have zinc sulfate reacts with sodium chloride, producing zinc chloride and sodium sulfate. All right, well, the first thing is zinc sulfate. Now remember, zinc is special because it always forms the same charge. Remember, it always forms a +2 charge. So we have Zn +2. Then sulfate, which is one of our polyatomic ions, is SO4 -2. So if we're writing that out as a compound, it would just be Zn SO4. Then next up, sodium chloride. So sodium is Na +1 and chloride, Cl -1. So the +1 and -1 would cancel each other out. So it's just NaCl. And then it goes on to produce now zinc chloride. So we look, zinc is +2, chlorine is -1. So ZnCl2. And then sodium sulfate. So plus, now sodium sulfate. So sodium is +1 and sulfate is -2. So remember, as we switch those charges, it should be Na2 SO4. Now, one thing maybe I should have pointed out a little bit earlier is as you're writing your products, remember it's always the cation first, anion second. So that'll be something that's a little bit more important when we talk about how to write these equations based on predicting products. But anyways, before we finish, remember we do have to balance. So as we're going through and balancing these, let's start off with our zincs. Zincs, they check out. Sulfate, the SO4, there's one on the left, one on the right, so those check out. Now sodiums, we got one on the left, but two on the right. So we had a big 2 there. And then afterwards, let's check chlorines. So after adding that 2, we have 2 on the left and 2 on the right. That means perfect. We did it. Alrighty, guys, that's it for this video. So take a few minutes, practice balancing, practice writing stuff out. And then when you guys are ready, we're going to come back and we're actually going to talk about how to get these products based on the reaction that we're seeing. All right, I'll see you guys on the next one.